Welcome to this presentation where we will discuss the reason why companies should identify why they need a business architecture and how they might determine which one to choose from the more than 50 architectures available. The complexity and cost of man-made systems has grown to unprecedented levels. For many organizations, developing or utilizing IT systems, achieving ROI, return on investment, and expected benefits from IT is still under question. These organizations have faced serious difficulties in aligning business needs and technology. In the late 80s, a new discipline appeared to address these challenges. It was the birth of enterprise architecture. It developed rapidly and is still evolving. In the last 30 years, many different enterprise architecture methodologies have appeared. Today, it has become hard to decide, does an organization need any enterprise architectural methodology? Is it required to comply to any enterprise architecture standards? Is it necessary to utilize specific enterprise architectural tools? And if yes, which one do you choose? The AMSIS training and certification program is designed to help professionals and organizations better understand the architectural approach, to choose a suitable architectural methodology, standards and tools. It will also help to achieve competencies required to succeed as enterprise and information systems architects. The aim of this presentation is to make an overview of the AMSIS Foundation training program content and certification scheme. Let me move on to the architectural approach. The architectural approach is for organizations developing and utilizing IT systems. But what is a system? According to ISO 15288, Systems and Software Engineering, system lifecycle processes, it is a combination of interacting elements organized to achieve one or more stated purposes. Examples of IT systems are enterprise resource management systems, ERP, a customer relationship management system, CRM, a corporate-wide area network, or WAN, and the like. From an enterprise architecture point of view, elements of a system could be software, hardware, information, operating systems, applications, firmware, people, business processes, organizations, or any combination of them. From an architecture approaches point of view, what we call architecture represents something like snapshots of the system. Let us demonstrate this concept with an example from the construction business. In the picture, we can see two totally different states of the same system. One of them, to the left, represents the systems element, building materials, bricks, pipes, tiles, etc., situated in a specific environment, a warehouse perhaps, organized with a specific purpose, to provide materials for home building projects, and to satisfy specific requirements, subcontractors who are responsible for supplies or bills of materials. The second one, the home, represents the same system elements, building materials, bricks, pipes, tiles, etc., but situated in a specific environment, a home, organized with a specific purpose, to provide a home where somebody can live, and to satisfy specific requirements, users who will live in that home. It is interesting to answer the question, which one of these organizations is better, the warehouse or the home? Intuitively, you might answer the home, of course, and probably this will be right if you live at that home. But if you are the warehouse manager, for sure the warehouse organization will look better for you. Hence we can make several conclusions. Any system has some architecture. There is no single universal good architecture which makes everybody happy. The quality of a good architecture depends on the purpose of the system. But what will happen if we let both systems, the warehouse and the home, develop independently? Probably chaos. Maybe the home architecture will require materials that are not available, or even not known to the warehouse management. Maybe the delivery time for some of the materials will not be acceptable. Some home users will not be happy to live in a home which does not comply to the architectural design. The warehouse will have troubles too. Some bills of materials will not be provided. Maybe materials nobody needs will be bought and simply left on the warehouse shelves. How do the organisations resolve these kind of issues? By assigning the role enterprise architect to somebody and by authorising him to take care of the system's architecture. It does not matter what name each organisation gives to this role: systems architect, software architect, enterprise architect, but this role is responsible for the enterprise architecture management. In the real business environment, the enterprise architect role has two persona. As you know, persona in ancient Greece was a tragedy mask, and if not properly managed, the enterprise architecture could cause a tragedy. The first persona is an organisational architect. The architect is responsible for the corporate business model design, for delivering value to the customers, for corporate organisation chart establishment, for corporate roles and responsibilities definition, for business process development and the like. The second persona is of a system architect. This architect is responsible for aligning IT to the business needs, for technical architectures, for deploying IT solutions. When organisations grow, the organisational architect persona probably will have no capacity to manage systems architecture too. It is at this point that the systems architect persona's role will be managed by somebody new, an individual or a team. Somebody will ask, why do we need enterprise architectural methodologies if we have well-known standards and best practices for IT management, like ITIL, ISO 20000, IT Service Management Systems, ISO 27001, IT Security Management Systems, ISO 22301, Business Continuity Management Systems, PRINCE2 Project Management Method, and RUP, the Rational Unified Process for Software Development? Well, the answer is simple. These address specific parts of an organisation's governance, but they leave many gaps. For instance, PRINCE2 is widely used for IT project management, but does not provide guidance for IT operations. ISO 20000 defines requirements to IT service delivery, but does not provide guidance on how to do it. These enterprise architectural methodologies, standards and best practices are highly complementary. Organisations developing or utilising IT systems often face severe challenges related to systems architectures. Managing IT systems complexity, cost and alignment to business needs is for sure a challenge, as there is a need for keeping more and more complex systems and expensive IT systems and infrastructures aligned with business needs. As a result, it is difficult to say whether IT is well managed. After execution of the entire process for developing and implementing an IT solution, they find there is a huge gap between the original requirements and the implemented system. Unexpected usage of the system. Difficulties when ordering and or integrating third parties' IT systems. The same in case of outsourcing. Changes in a specific system leads to failure in other parts of the IT infrastructure. When an employee leaves the organisation, valuable knowledge and information about the systems also leaves the organisation. The system architects should address a variety of questions. What are the relations between organisations' hardware and software? Is the technical architecture appropriate? Does it provide the necessary computing power for today's needs? And what about tomorrow's needs? What will happen if the organisation decides to use cloud solutions or software as a service? Or our software system was designed for payment transactions processing. It must not stop while the transaction is in process. Do we need transaction processing machines? Or what are the users of the system? Who is responsible for what? Is there any application without owner? It is a long list of architectural challenges to be addressed. How the architectural approach can help. The architectural approach is for large and complex systems. It provides skills and tools never used before. Fundamental for the architectural approach is so-called architecture description. It is a work product used to express an architecture. The architecture description is used to document the system architecture in a formal way, which allows easy to answer questions about that system implementation, deployment, integration, modes of operation, and the like. It also provides information about specific systems aspects. There are two important elements of mechanisms to developing an architecture. The first is the so-called architecture description languages, ADL, and methods. The architecture description languages and methods are used to express architecture descriptions. There are formal languages, often graphical, which allow architectures, business processes, models, behavior, relations, how specific items function, and the like to be described and defined. Popular examples for ADLs and methods are the Universal Modeling Language, UML, Business Process Model and Notation, BPMN, Archimate, SysML, and the IDEF family of methods. There is a wide variety of ADLs and methods. Many organizations expect they will address the architectural issues by implementing some of them. But by themselves, these do not provide more than any other language. The ADLs and methods are only beneficial when used in proper context. That's why the successful implementation of the architectural approach usually starts with the choice of the second mechanism, the so-called architecture framework. An architecture framework establishes a common practice for creating, interpreting, analyzing and using architecture descriptions within a particular domain of application or stakeholder community. An AF can comprise best practices and work disciplines and can establish specific rules and culture. The most popular architecture frameworks are the Zachman framework, which marked the beginning of the architectural approach, the Open Group Architecture Framework, or TOGAF, the US Department of Defense Architecture Framework, or DODAF, the US Government Federal Enterprise Architecture Framework, or FEA, Gartner's Method, and NATO's Architecture Framework, NAF. It is clear that for many organizations, the choice of a suitable architecture description languages and the methods is not an easy task. A lot of questions arise. Is this actually an architecture framework? Is this language a real architecture description language? Are there any standards the AFs and ADLs should comply to? And here comes the international standard ISO IEC IEEE 42010 Systems and Software Engineering Architecture Description. As we shall see later in this presentation, ISO 42010 provides the architectural approach, common language, systemizes fundamental architectural concepts, defines the mandatory requirements to architecture descriptions, and architecture description languages. The problem with ISO 42010 is that it puts forward requirements that do not tell organization how to make things happen. This is where the AMSIS program helps. It offers some basic processes utilized by the architectural approach. So how did this concept start? Well, the beginning was the Zachman framework. John Zachman marked the beginning of the architectural approach. Originally, the Zachman framework was a taxonomy or a scheme of classification. The Zachman framework provides taxonomy for classification of architectural artifacts. Zachman originally explained his taxonomy using the building industry as an analogy. The Zachman taxonomy uses 2 dimensions to organize the architectural artifacts. The first dimension, perspectives, is for the players in the game. Zachman identifies 6 players having very specific roles and viewpoints to the system. These players are the planner, who defines the aims, scope, and the context of the system, the owner, who is responsible for the system's conceptual model, the designer, who is responsible for the system's logical model, the builder, who is responsible for the system's physical model, the subcontractor, who provides detailed descriptions for existing and/or future solutions, and the user, who exploits a functioning enterprise. Each of these roles differs from the other and has its own unique perspective to the system. At the same time, these roles represent a usual organization hierarchy, top to down, each of them having an increasing level of authority. For example, the planner could be the CEO of an organization who wants to have a new accounting system. He will not develop or operate the system, but he identifies the need of such a system and delegates specific duties to the other roles. The role of the owner could be played by the CFO. He will not develop the accounting system, but will be responsible for the process of utilization. He will define the requirements for accounting system customization, to the chart of accounts, to the exploitation schedule, and the like. The role of users will be played by the accountants, who will enter the accounting transactions, make records, produce reports, etc. The second dimension, aspects, provides 6 descriptive foci for the architectural artifacts, answering 6 very basic questions: what, how, where, who, when, and why. This slide depicts several perspectives according to the Zachman taxonomy, and to testify the architecture's origins are as old as the Middle Earth. This slide depicts Zachman's framework grid. Take a moment to look at it. Now let us see how it works. Let us suppose the organisation is a telecom operator which goes to implement a new billing system. Part of it is processing clients' claims. Let us look at the planner how model. The planner could decide the client's claims are to be processed by a service desk and call centre. The designer how model could be to use ITIL service desk functions or ISO 20000 incidents management process. Both of them do not depend upon any technology. The subcontractor how model will describe the specific service desk solution, e.g. some specific vendor solution like Unify, Avaya, Asterisk, and the like. The implementation rationale for the Zachman framework can be flexible as described here. Now we come to the international standard ISO 42010, Systems and Software Engineering, Architecture Description. It will provide us with common architectural approach language, concepts and requirements, which we can use as criteria when studying specific architectural methodologies. The concepts, terminology, requirements and guidance provided by this international standard are the result of common expert consensus. ISO 42010 specifies requirements to the manner in which architecture descriptions of systems are organized and expressed, and to architecture viewpoints, architecture frameworks and architecture description languages for use in architecture descriptions. All of the requirements are mandatory. The standards use the word shall to mark the mandatory requirements. ISO 42010 provides some recommendations and guidance on specifying architecture viewpoints. These are not mandatory. The word should is used to mark that recommendation. ISO 42010 demonstrates its use with other standards as well. The separate topics of an international standards topic is called clause. The clauses are used for reference. This is the ISO 42010 definition for architecture. Have in mind that other architectural methodologies definitions can differ from this one. The definition says an architecture comprises fundamental concepts or properties of a system. These are attributes of the system as a whole and of its elements and relationships in particular. Anytime the system is considered in its environment, the architecture comprises the principles of that system's design and evolution. Hence, the architecture takes care about its future evolution. In fact, the architecture contains something like a DNA of the system. ISO 42010 is about the architecture description, the work product used to express an architecture. Here are two definitions of architecture framework and architecting. What you notice is that the Zachman framework has almost all of the architecture framework's definitions attributes. Architecture view and architecture viewpoint definitions are important because they help to express the architecture from each of the specific stakeholders' perspectives. This scheme depicts key concepts pertaining to systems and their architectures as a context for understanding the practice of architecture description. There is a stakeholder who has his own interests in a system. The system is situated in its environment. The system exhibits architecture expressed by architecture description. Obviously, the architecture mirrors the stakeholder's perspective. This scheme represents the conceptual model of an architecture description. ISO 42010 distinguishes between an architecture of a system and an architecture description. The architecture description is a work product. An architecture is abstract, consisting of concepts and properties. There is a stakeholder who has concerns with respect to the system of interest considered in relation to its environment. Concerns arise throughout the life cycle from the system needs and requirements. A concern could be manifested in any form, such as requirements, restrictions, design constraints, assumptions, architecture decisions, etc. Any architecture description includes one or more architecture views. Any architecture view addresses one or more stakeholders' concerns. An architecture view expresses the architecture of the system in accordance with an architecture viewpoint. There are two aspects to a viewpoint: the concern it frames for stakeholders and the conventions it establishes on views. An architecture viewpoint frames one or more concerns. An architecture view is composed of one or more architecture models. An architecture model uses modelling conventions appropriate to the concerns to be addressed. These conventions are specified by the model kind, governing that model. The architecture frameworks can be used to create architecture descriptions, to develop architecture modelling tools and architecting methods, for establishing processes to facilitate communications, commitments, and interoperations between multiple projects and/or organisations. The scheme on this slide depicts an architecture framework content. An architecture description language is any form of expression used in architecture descriptions. The scheme on the slide depicts the conceptual model of an architecture description language. Examples of ADLs which comply to this standard are SysML, Archimate, UML, and BPMN. In summary, ISO 42010's focus is on architecture description, concepts and terminology. It defines requirements, crosses boundaries and is used by the key architecture frameworks and architecture design languages. TOGAF is an AF, architecture framework, owned by the Open Group. It is an open standard available to the public. You can find it on the Open Group website. TOGAF provides methods and tools to manage the whole life cycle of an enterprise architecture. It complies to ISO 42010 requirements. For TOGAF, the word architecture has two meanings depending upon the context. Firstly, it is a formal description of a system or a detailed plan of the system at component level to guide its implementation. And secondly, it is the structure of components, their interrelationships, and the principles and guidelines governing their design and evolution over time. TOGAF is designed to support four commonly accepted architecture domains: the business architecture, the data architecture, the application architecture, and the technology architecture. The most important part of TOGAF is the architecture development method, known as ADM. The ADM allows you to view TOGAF as an architectural process, and TOGAF complements Zachman's framework. Zachman tells us how to organize the architecture artifacts. TOGAF tells us how to do it. The ADM provides an interactive cycle of continuous architecture definitions and realizations, which allows organizations to transform their enterprises in a controlled manner. The TOGAF's architecture development cycle is shown on this slide. TOGAF includes the enterprise continuum concept, which explains how generic solutions can be leveraged and specialized in order to support the requirements of an individual organization. TOGAF views the process of creating specific enterprise architecture as moving from more generic to more specific architectures. In summary, TOGAF is a favorite of ICT companies, is open, and is global. It supports accepted architecture domains and has an architecture development method. It also provides its own ADL, Archimate. Let me now turn my attentions to DODAF. DODAF 2.0 is the US Department of Defense architecture framework. DODAF is fundamentally about creating a coherent model of the enterprise to enable effective decision-making. DODAF version 2.0 focuses on architectural data. Data can be collected, organized, and stored by architecture tools developed by commercial sources. It is anticipated that these tools will adopt the DODAF meta model for the exchange of architectural data. DODAF was designed to serve one of the most complex organizations in the world. Its primary goal is to represent complex architectural data in a way that is understandable to many stakeholders and communities involved in developing, delivering, and sustaining capabilities in support of the stakeholders' mission. DODAF achieves that goal by dividing the problem space into manageable pieces according to each stakeholder's viewpoint. DODAF calls them DODAF-defined models. DODAF architectural description is a set of viewpoints. DODAF organizes the DODAF-described models into viewpoints as depicted on this slide. These viewpoints are the Department of Defense's business-specific. For instance, the capability viewpoint articulates the capability requirement and logistics aspects. The operational viewpoint articulates operational scenarios, etc. DODAF 2.0 has a 6-step architecture development process. The process is depicted on this slide. The process ensures concordance between views in architectural descriptions. The views created as a result of the architecture development process provides visual rendering of the underlying architectural data and conveys information of interest from the architectural description needed by specific stakeholders, communities, or decision makers. In summary, DODAF is focused more on complex, large organizations. It complies with ISO 42010 and uses Zachman's taxonomy. Vendors to the US military have a vested interest in understanding DODAF. Next, we move on to the Federal Enterprise Architecture. FEA is the US government Federal Enterprise Architecture Framework. It describes a suite of tools to help government planners implement the common approach to federal enterprise architecture. FEA standardizes development and the use of architectures within and between the US state agencies. It uses architectures in a lean way to eliminate waste and duplication. It uses the consolidated reference model to provide common language and framework to describe and analyze investments. The Federal Enterprise Architecture Framework is depicted in this slide. It is used on 4 primary outcomes: service delivery. The core role of state agencies is services delivery. Functional integration means interoperability between programs, systems, and services. Resource optimization means optimization of public fund usage for systems. Authoritative reference. The enterprise architecture is recognized as authoritative reference for the design and documentation of systems and services. There are 8 levels of scope for implementing an architecture. They are international, national, federal, sector, agency, segment, system, and application. There are also 8 basic elements that must be present and be designed to work together in each agency program: governance, principles, method, tools, standards, use, reporting, and audit. These ensure that agency programs are complete and can be effective in developing solutions that support planning and decision-making. The Consolidated References Model consists of a set of 6 reference models as shown in this picture. These are designed to facilitate cross-agency analysis and the identification of duplicated investments. Collectively, the reference models comprise a framework for describing important elements of federal agency operations in a common and consistent way. The real value is that the FEA provides a framework to describe the current status of an agency, to plan the future status, and the migration to it. Because of standardization, different agencies describing their architectures could identify gaps between their current architecture and the reference model. Filling that gap should be part of their architecture development. At the same time, if another agency has resolved similar issues, it could be used to fill that gap. The collaborative planning methodology shown in this slide is a simple, repeatable process designed to help planning and implementation of enterprise architecture. This slide shows the hierarchical relationship of the major areas of the architecture of the FEA. It also shows how the architecture can be decomposed into segments. These segments follow structural or functional lines in the organization. You also see how shared services would be positioned. The FEA also provides a comprehensive taxonomy. In summary, the FEA is the most developed offering, the most common approach. It also provides quality documentation in terms of taxonomy and processes. What is an architecture description language and method? It is clear the architecture description languages are important tools for architecture description and modelling. There are many ADLs available from open or commercial sources. These ADLs are in the form of standards, graphical notations, or software products. The choice of an ADL should depend upon a number of factors. The architect should consider a number of questions like the architecture framework the organization uses. Does it work better with a specific ADL? For instance, the Open Group supports TOGAF and Archimate. Hence, we might suppose that TOGAF and Archimate is a good pair. Which ADL should my organization's architects use? What is the purpose? To describe a process? To describe functionality? Which ADL should our programmers know? Here you can see the family of integrated definition methods used in architecting. It represents a family of methods designed to model how a system or its elements function works, to model organizations, information, assets, etc. How can you learn about architecture modeling and gain accreditation? The AMSIS Foundation course will provide 24 hours of training followed by an examination. It will be modular with business cases. It will be both tutor-led lectures and discussions to enable all types of learner to benefit. The curriculum comprises overview of the main enterprise architecture approach concepts, like architecture frameworks, architecture description languages, methods, and architecture development processes. It provides knowledge and rationale about the most used architecture frameworks and standards as ISO 42010, Zachman Framework, TOGAF, DODAF, FEA, as well as about architecture description languages and methods, UML, Archimate, BPMN, and IDEF. The AMSIS Foundation helps students to orient in the field of architectural approach and to choose their path of development as systems architects. It provides rationale about the choice of appropriate architecture framework, architecture description languages, methods and tools. It will conclude with an accreditation exam managed and delivered by the Global Trusted Examination Institute, PeopleCert. There will be a variety of materials used with a fully proctored pass-fail examination. PeopleCert will issue certificates for those who pass the AMSIS Foundation exam. A certificate of attendance will also be issued. Thank you for taking the time to listen to this presentation. Please contact AMSIS on www.amsis.bg or PeopleCert on www.peoplecert.org for further information.